Hello everyone. In today's session, we are going to see the two types of SJF scheduling algorithm. In previous session itself, we have seen what is SJF scheduling and we have seen an example problems to solve under SJF scheduling algorithm. Today we are going to see the two major categories of SJF. First one is preemptive SJF, next is non-preemptive SJF. Preemptive SJF is also known as shortest remaining time first algorithm. Preemptive SJF is nothing but if a shortest burst time process arrives while a longest burst time process is executing in the CPU, the current process which is executing with the largest burst time will be preempted and it will be placed in the waiting queue, and the newly arrived process with the shortest burst time will be allocated for the CPU and it will be executing. That is preemptive SJF. Non-preemptive SJF is nothing but even though while a largest burst time process is executing and a smallest burst time process arrives in the waiting queue, the process which is currently executing will be completing its process and then only the next process which arrives with the smallest burst time will be allocated for its execution. That is non-preemptive. Let's see an example to solve under preemptive and non-preemptive SJF. Okay. This is our example problem. The inputs given are the four process arrives at the time interval of 0, 1, 2 and 3 and its consecutive burst time of process are given. The first thing we will be finding is its Gantt chart. In this, at the time of 0 milliseconds, the process P1 arrives. So it will be allocated for its execution in the CPU. At the time of 0 milliseconds, P1 starts its execution and it is executing till 1 millisecond. At the time of 1 millisecond, the process P2 arrives. So now the process P2 has the burst time of 4 milliseconds, but the process P1 has the burst time of 8 milliseconds. Currently it has executed for 1 millisecond, right? So currently the remaining burst time of process P1 is 8 minus 1, 7 milliseconds. But for process P2 which have newly arrived, its burst time is 4 milliseconds. Since this is example under preemptive SJF, if a new process with smallest burst time arrives, currently executing largest burst time process will be preempted and it will be placed in the waiting queue. So P1 will be preempted at the time interval of 1 millisecond and it will be placed in the waiting queue. Then the process P2 will start its execution and process P2 starts at the time interval of 1 millisecond. Its burst time is 4 milliseconds. So it will start its execution and from 1 to 2 process P2 will be executing, and at the time of 2 milliseconds another process P3 will be arriving. So the burst time of P2 and P3 will be compared. Since P2 has the lowest burst time, P2 will be continuing its execution till the time interval of 3 milliseconds. At the time of 3 milliseconds, again the process P4 will be arriving. Again the comparison will be done. Since P2 is smallest, the process P2 will start its execution and it will be continuing. So the process P2 will be occupying the CPU from 1 millisecond till the completion of its process. 1 plus 4 equal to 5 is the completion time of process P2. Then next, at the time of 5 millisecond, all the process will be waiting in the waiting queue. So the burst time of all the three processes P1, P3 and P4 will be compared. In that the process P1 will be currently having the burst time balance of 7 millisecond. P3 will be having the burst time 9 millisecond. P4 is having 5 millisecond. So P4 is having the smallest burst time. So P4 will be allocated for its execution. P4 starts its execution at 5 millisecond plus its burst time, it's 10. So the completion time of process P4 is 10. Then next, again the process P1 and P3 will be compared. P1 has the remaining burst time of 7 milliseconds. P3 is having burst time of 9 milliseconds. So comparatively, P1 is having lowest burst time. So P1 will be allocated for the execution. P1 starts at 10 millisecond and 10 plus 7 equal to 17. 17 is the completion time of process P1. Next, finally, the process P3 is having 9 millisecond is in the queue. It is getting allocated for its execution. P3 starts at 17 millisecond plus its burst time 9 equal to 26 is the completion time of process P3. So from this Gantt chart, we will be finding the turnaround time and we will be finding the waiting time. What is the formula for finding the turnaround time? Turnaround time equal to completion time minus arrival time. So for process P1, P2, P3 and P4, we are finding the process turnaround time using that formula. 17 minus 0 equal to 17 is the burst time of process P1, turnaround time of process P1. Then P2, 5 minus 1 equal to 4 is the turnaround time of process P2. P3 will be having turnaround time of 24 and P4 will be consecutively having turnaround time of 7 milliseconds. For finding the average, we will be summing all those P1, P2, P3, P4 and find the average. It is 12.25 milliseconds. Then using this turnaround time, we will be finding the waiting time. Waiting time formula is equal to turnaround time minus burst time. So for process P1, its turnaround time is 17 minus its burst time is 8 equal to 9 is the waiting time of process P1. Consecutively for P2, P3 and P4, the waiting times are calculated using the formula. And for finding the average waiting time, we will be summing all those waiting times of process P1, P2, P3, P4 and we will find the average. The average will be in 6.5 milliseconds. This is the preemptive SJF problem solving technique. Let's see the same example problem to be solved under non-preemptive SJF.